Hello, I'm Steven. I am Business Development Manager in Advantech. I am promoting Advantech's robotic solutions, and I'm very glad to show you this development kit for robotic developers. To put up a robot, whether it's a mobile robot or a humanoid robot, you need a lot of different components and software modules. To accelerate this whole process, we make everything in this one box. It's a development kit consisting of a single board computer, all the accessories, and 4 counts. Let's take a look at it. First of all, inside the box, we'll find 4 cameras. You can choose between MIPI cameras or GMSL cameras. These cameras are with low latency, high resolution, high bandwidth, but they are not exactly compatible with any computing platform, for example, Intel. So we made it possible with a bunch of great camera vendors around the world and get the driver ready at the OS level and at the ROS level. So these are the cameras in the camera. In this smaller box, you will find all the cables and connectors for COM boards and CAN bus. And this special cable is made for MIPI camera. Of course, there are some screws and a Ubuntu sticker because we've included a Ubuntu Classic license, so you can probably put the sticker on top of your board. And here comes the most exciting part. In this box, you will find a industrial grade single computer based on Intel Core Ultra with very, very sufficient computing power and built-in AI capability. And in this case, it's a MIPI expansion board for the cameras. And of course, you will need a cooling solution. So that's why we also include a fan kit. Here we go. This is the fan kit we're going to mount in a few seconds. But what's not included is a adapter and power cord, because you can get this almost in anywhere around the world. So we suggest you to purchase a 150 watts power supply and the power cord according to this specific connector in your region. Now we're going to put up the most important parts and then try to show what you can achieve on a demo AMR like this. And then we will take a glance at the Ubuntu desktop and see if the ROS environment is really in it. And we'll try to maneuver this robot and see what you can get from the different camera and LiDAR images. So these are the key components to start your first robotic application. And let's try to put them up. First of all, let's take out the AFE-R360 Intel Core Ultra single board computer and put this DDR5 over here. Just carefully insert the golden finger and press it. That's done. And then let's do the fan kit. Make sure that the screws are mounted on top of their holes. And of course, you need a screwdriver. All right. Just to give you an example, and then make sure that you connect the power supply of the fan kit in the slots. If you are not sure of the connectors, we've got user manual in the box and on the product page, so you can always get a very detailed explanation of all the components and the standard uh, installation operation procedures. Now, let's deal with the components on the back side of the board. This is a NVMe type storage. You can put it on one of these two M.2 slots. Right, and then make sure that you get a screwdriver to fix it over there. And now, this is the most innovative part. We make it very modularized to support either MIPI cameras using this expansion board or GMSL camera with 4 VAPA connectors with another expansion board. And in fact, we can support up to 6 GMSL cameras using AFE-R360. To install this, make sure that the connectors match each other, press it, and then screw them. Make sure that this fixed. Now we're going to install this InnoDisc MIPI camera, and with a special cable. The bigger end goes with the camera, and make sure that the golden fingers face the board side, and pull out the lock, and then squeeze in the golden finger, the connector, and push the lock, and then it's fixed. It's the same on the other end. There are 4 MIPI connectors. Again, golden finger facing down to the board, any one of them. And this time, just press the lock, and then it's fixed. All right, so it's the same process, similar process with GMSL board, except that the connectors are different. Now, that's all you need. And the power supply board with a battery, we can start our first robotic application. Let's take a look at the demo AMR made by Advantech application engineers. We don't manufacture the vehicle. In fact, our computer and the sensors can fit in any type of robots. In this case, it's a mobile robot for development purpose. These are omnidirectional wheels with a STM32 lower controller board. And we put the AFE-R360 over there. And that's basically what you get from the dev kit. And just to show you, that also supports the GMSL camera. So that's the GMSL apprenticeship installation board. And it connects to a RealSense D457 IP65 rate 3D camera and the 2D LiDAR. And of course, we also add Wi-Fi and some other communication modules. You can find all kinds of those accessories or peripherals from Advantech. Now, let's take a look at how it works and what we can expect in the software environment.
To begin with, Advantech maintains and pre-built a robotic development resource called Robotic Suite that goes with most of our robotic controllers on top of an operating system, most likely Linux Ubuntu. And in this Robotic Suite, you can find many toolkits that are commonly required to build up a robotic application. and AI inference. For example, we include all the necessary AI inference SDK released and maintained by the silicon vendor, in this case Intel, so that you don't have to download and find out where they are on the internet. In addition, we make sure that all the ROS toolkits library is included. And finally, we make sure that you can get data directly at the ROS level for particular sensors, for example, MIPI or GMSL cameras. So we don't just figure out the drivers, we also allow you to subscribe to the camera data or camera topics at the ROS level. Because everything is pre-built with the Ubuntu image, so you can see all of them in the same place in a Advantech folder once you get to the Ubuntu desktop. And you'll find all the drivers and ROS resources, open source tools, and some Advantech utilities on the desktop. Now we're going to check if ROS2 is already included. Let's open up the console and send a few command line to call the subscription and publication features as unique in the ROS environment. If ROS2 is not there, then you won't be able to see the talkers, to see the subscription publication working. And after that, we can quickly click open the RV's graphical user interface and see the physical model, the coordinates we built for this mobile robot. And that's also where you can enable particular sensor data and start building your application. So now we are going to select data directly from the sensor nodes. First of all, the MIPI camera we just installed. And then we are gonna to choose the depth camera and get depth or the relative distance data and show them onto this graphical user interface. Afterwards, I guess we are pretty much set and ready to maneuver the mobile robots, and while we move it around, and the surrounding environment is actually doing the SLAM task. That's simultaneous localization and mapping around the environment and see where the obstacles are. So it's building the map by itself. And this is a very important first step for your robot navigation. All in all, with this AFE-R360 development kit, you will be able to streamline your hardware and software development process for your first robotic application.